Imagine a future where the resources we desperately need aren't buried beneath our feet, but floating millions of miles away in the depths of space. This isn't a sci-fi dream, it's the emerging reality of asteroid mining, a frontier that could redefine our economy, reshape our industries, and unlock wealth on an astronomical scale. Welcome to the billion-dollar space gold rush. Asteroids, those rocky remnants left over from the formation of our solar system, are far more than just space debris. They're treasure troves of precious metals and rare elements, containing everything from gold and platinum to nickel and cobalt. Some asteroids are so metal-rich that they hold more value than the entire global economy combined. For instance, the asteroid 16 Psyche, located in the asteroid belt between Mars and Jupiter, is believed to contain enough nickel and iron to be worth an estimated $10 quintillion. That's quintillion, a number so large it almost defies comprehension. But why are we so interested in mining these celestial bodies? The answer lies in both opportunity and necessity. Here on Earth, many of the materials we rely on, like rare earth elements used in electronics and clean energy technologies, are becoming increasingly scarce. Mining these resources often comes at a significant environmental and human cost. Asteroid mining offers a solution, a way to tap into virtually limitless supplies without further depleting our planet or damaging its ecosystems. So, how does asteroid mining work? While the concept may sound simple, go to space, grab an asteroid, and bring back the goods, the reality is far more complex. The first step is identifying the right asteroids to target. Not all asteroids are created equal. Some are carbon-rich, others contain vast amounts of water, and others are packed with metals. Scientists and engineers use advanced telescopes and spectrometry to analyze asteroid compositions and determine their value. Once a target is selected, the next challenge is getting there. This requires highly advanced spacecraft capable of traveling millions of miles, landing on or attaching to the asteroid, and then extracting the desired materials. There are a few methods being considered for this. One involves robotic drills and extractors that mine the asteroid directly. Another involves bagging the asteroid in a large net and bringing it closer to Earth or into lunar orbit for processing. Some proposals even suggest using solar heat to vaporize materials on the asteroid's surface and then collecting the valuable elements. A key player in this space gold rush is water. While it might not seem as exciting as gold or platinum, water is incredibly valuable in space. It can be broken down into hydrogen and oxygen to create rocket fuel, effectively turning asteroids into cosmic gas stations. This capability could revolutionize space exploration by making deep space missions more feasible and cost-effective. Several companies and organizations are already gearing up to make asteroid mining a reality. Planetary Resources, founded in 2012, was one of the first to announce ambitious plans for mining asteroids, aiming to extract water and precious metals. Although the company faced financial difficulties, its legacy has inspired others. Deep Space Industries, another pioneer, focused on developing technologies to harvest resources from asteroids. Today, companies like TransAstra and government agencies like NASA are taking up the mantle, investing in the technology and infrastructure needed for asteroid mining. NASA, in particular, has made significant strides. The OSIRIS-REx mission successfully collected samples from the asteroid Bennu, proving that it's possible to retrieve material from these distant bodies. While the primary goal of this mission was scientific research, it's also a stepping stone toward commercial asteroid mining. NASA's upcoming mission to the metal-rich asteroid 16 Psyche could provide even more insights into the feasibility of mining valuable resources in space. Let's take a moment to dream big. What could asteroid mining actually do for us? Imagine a world where the scarcity of rare materials is a thing of the past. Industries like electronics, renewable energy, and even space exploration could flourish without the bottleneck of limited resources. Platinum and other precious metals could become more abundant, driving down costs and spurring innovation. The economic benefits would be monumental, creating new markets, jobs, and opportunities. But the potential goes beyond economics. By tapping into the resources of asteroids, we could reduce the environmental damage caused by terrestrial mining. No more scarring landscapes, polluting water supplies, or exploiting vulnerable communities. Instead, we could look to the skies for sustainable solutions. Asteroid mining could also serve as a critical stepping stone for humanity's expansion into space, providing the materials needed to build space habitats, fuel deep space missions, and create a self-sustaining presence beyond Earth. Of course, this vision comes with challenges. The technology needed for asteroid mining is still in its infancy, requiring significant advancements in spacecraft design, robotics, and material extraction. Then there's the question of cost. Launching missions to space is expensive, and the return on investment will need to justify these astronomical expenses. However, as companies like SpaceX continue to drive down the cost of space travel, the economics of asteroid mining are becoming increasingly viable. Legal and regulatory hurdles also loom large. Who owns the resources extracted from an asteroid? Can a private company claim an entire asteroid as its property? These questions remain unanswered, as current space laws, like the Outer Space Treaty of 1967, were written long before asteroid mining was a practical consideration. The treaty prohibits nations from claiming celestial bodies, but it's less clear about the rights of private entities. Efforts like the US Commercial Space Launch Competitiveness Act of 2015 have started to address these issues, granting American companies the rights to resources they mine in space. But international consensus is still needed. Despite these challenges, the momentum behind asteroid mining is undeniable. The combination of scientific curiosity, technological innovation, and economic potential is driving a new era of exploration. It's not just about the resources we can extract. It's about what those resources enable us to achieve. Asteroid mining could be the catalyst that propels humanity into a future where space is not just the final frontier, but a new home. The journey to that future will require collaboration between governments, private companies, and the scientific community. It will demand breakthroughs in engineering, robotics, and space travel, as well as new frameworks for international cooperation and regulation. But if we can overcome these obstacles, the rewards will be staggering. As we stand on the cusp of this new frontier, one thing is clear. Asteroid mining isn't just about extracting resources. It's about redefining our relationship with the universe. For the first time in history, we have the tools and knowledge to look beyond our planet and see the cosmos not as an empty void, but as a realm of infinite potential. The billion-dollar space gold rush has begun, and its impact could be as transformative as any discovery in human history. The question now is, how far are we willing to go to claim the stars?